In this video, we are talking about the null and alternative hypothesis, and also the outcomes and the type 1 and type 2 errors. And this is the introduction to hypothesis testing for this chapter. Okay, so let's first consider a problem that we have here. Consider the following scenario. Our class had 50 students. 25 students are junior, and the other 25 students are senior. Now, I have 20 movie tickets from a friend, and I want to give out these 20 tickets to 20 random students in the class. It turns out that 19 senior students received the tickets, and only one junior student received the remaining ticket. Then the students in the class make a claim that I favor the senior group, or using the statistical language, they said that the probability of senior getting the ticket is bigger than 50%, or P is bigger than 0.5. The proportion is bigger than 0.5. If this is a random process, then junior and senior students should have equal chance P equals 50 or 0.5 of getting the ticket. So the goal in this chapter is that we will present the standard methods for testing such the claims that you see here in this example, that the senior students are more likely to get the tickets, or P is bigger than 0.5 than the other junior students in my class. Okay, so before we do the testing, we have to know a few more new definitions for this chapter. Hypothesis. Hypothesis is a claim about a population parameter. It could be proportion, it could be a mean, or it could be a standard deviation of the population. So for example, I may have a hypothesis that the average GPA of the high school students is higher than 3.0. Or I claim that the population mean is bigger than 3.0. So this is one of the examples of the hypothesis. Hypothesis test, or we call it the test of significance. This is a procedure for testing a claim. Testing this claim about a population parameter, and we use a sample data to do the testing because it's impossible to gain access to the entire population. So they claim that the average GPA of high school students is higher than 3.0, but there's no way that I can go and collect all the scores or the GPA of all the high school students in the entire country. There's no way that I can do that. However, I can have a sample of a group of some schools, and then I use the sample data. I do that testing. And then there are two types of statistical hypotheses. The first one is a null hypothesis, or we call it H0. H0. The null hypothesis, or H0, this is a statement that the value of a population parameter such as proportion, mean, or standard deviation is equal to some claim value. And the statement of no change or no effect or no difference, and this is assumed true until evidence indicates otherwise. The next one, the other one, is the alternative hypothesis H1. This is a statement that the parameter has a value that somehow differs from the null hypothesis here. And the statement that we are trying to find the evidence to support. The statement that has some changes occur different from the original circumstances. So H0 is the null hypothesis. H1 is the alternative hypothesis. We'll see a few examples for these two statistical procedure. Okay, the next objective is for the type of hypothesis test. We have three cases: two tails, left tail, and a right tail. We conduct the hypothesis test by assuming that the proportion, the mean, or the standard deviation is equal to some specified value. And therefore, the null hypothesis always involves equality or the equal sign. Right, the equal sign, equality. So we assume that the proportion, the mean, or the standard deviation is equal to some existing value. So the null hypothesis or the H0 always involve equality or the equal sign. Now let's focus on the first one first. For the two tails test, so we have the distribution. Two tails mean we have one tail over here and then another tail on the left side. So we let the H0, the null hypothesis, that parameter equals some value. And then the H1, we claim that that parameter now is not equal to some value. So we are trying to find the evidence to support the alternative hypothesis. So the different side, the not equal side, represent for the two tail test, two tails. So we use a different size, not equal. For the left tail test, we let the H0, the null hypothesis. Again, the null hypothesis always has the equal sign. The parameter equal to some existing value. And we are trying to have a claim which is the alternative hypothesis H1, which is the parameter now is less than some value. So there's a tip to remember. Left means the error is pointing to the left, or the parameter is less than some value. So it's pointing to the left. So the left tail only. There's no right tail. And then lastly is the right tail. It's pointing to the right. Parameter is bigger than some value. And this is the claim. And this is the right tail. Okay. Let's move on to the next topic. Now, we never accept the null hypothesis H1. So we never support that. We never accept. Because we cannot get, or we cannot gain access to the entire population. And we cannot know the true population parameter 100%. There's no way that you can ask every single person in the United States if you want to do some kind of testing, right? Some kind of researching. We cannot gain access to the entire population, and therefore we cannot know exactly the true value of the population parameter 100%. We instead use the phrase fail to reject the null hypothesis. So we fail to reject to mean that we don't have enough strong evidence to warrant the rejection of the null hypothesis. So it's likely similar to the case that you are going to the court system. We never say a defendant innocent, but we instead say the defendant is not guilty. It's similar in this case, right? We never say you are innocent, but you say that you are not guilty because we don't have enough information to say that you are guilty. But we are not 100% sure if you are innocent or not. Okay, let's go over one example. The first one. Suppose we want to determine whether a coin is fair and balanced. A null hypothesis might be that half the flips would result in heads, and then half the other flips would result in tails if the coin is fair and balanced. Then if you're flipping, for example, 1,000 times, then half of the flip would give you the head and the other half should give you the tails. Then the alternative hypothesis might be that the number of the heads and the tails would be very different. So we can express these hypotheses using the symbolics, the notation that we discussed earlier. The null hypothesis, remember the null hypothesis always has the equal sign involved. So H naught, the proportion is equal to 50. That means under the normal circumstances, under the normal cases, then half of the flip would be the head and half of the flip would be the tail for a balanced and fair coin, and therefore the proportion should equal to 50 or 0.5. And then we make the claim. The claim is the alternative hypothesis. We said that the proportion should not be equal to 0.5 or very different, or different mean not equal. So this is an example of how to construct the null hypothesis and alternative hypothesis. Another example: a pharmaceutical company is producing the Advil pills up to 50 mg dose. However, the manufacturer is worried that the machine that making the pills has come out of calibration and is making less dose than it should be. So what should be the null hypothesis and the alternative hypothesis? Well, we know that the null hypothesis has the equal sign. So under the normal circumstances, the mean should produce 250 mg or the mean should be equal to 50. If there's nothing changed, if there's nothing affecting the system, then this is the normal cases. Right? All the cases we should have the mean to be 250. However, now there's a claim that, okay, maybe it's less than. So the mean now is less than 250. So this is the claim. The claim is the alternative hypothesis, H naught. So the original claim, the null hypothesis, is saying that if you buy an Advil bottle up to 50 mg dose, you would expect every pill has the amount of 250 mg exactly. However, we are trying to support the other claim or alternative hypothesis that the mean dosage of the pill is less than 250 mg. Okay, the next objective in this video is about the errors in hypothesis test. So at the end of hypothesis testing procedures, we either reject or we fail to reject the null hypothesis. Null hypothesis is H naught. And sometimes we do have some errors. Of course, there's nothing perfect. There are two types of errors, type 1, or sometimes we call that the alpha, or type 2 errors, or sometimes we call that the beta. The type 1 of error is when we reject the null hypothesis when it is true. RT, reject H naught when it is true. Type 2 error, we fail to reject the null hypothesis when it is false. So we only focus on the hypothesis, the null hypothesis, when we talk about type 1 or type 2 error. So FF, fail to reject H naught when it is false. Reject H naught when it is true. So RT, FT, FF. Now the way that I remember this, these two types of errors, I see the two letter F, it should be the type 2. And if I don't see any F here, that should be type 1. So just a way for me to remember. If you see the double, the two F letters here, that's type 2. And then the other one should be type 1. So RT and FF fail to reject when it is false and reject when it is true. And in this table is just the demonstration of the errors here. And note that the alpha, or the level of significance, is the same concept that we used in the earlier chapters for constructing the confidence intervals. It is the probability of the type 1 error. That's why you see now here. And type 1 error is the probability of rejecting the null hypothesis when it is true ft. It is chosen by the researcher before the sample data is collected. So normally it's given for you. Okay, let's go over this sample. According to the Centers for Disease Control, CDC, 15.2% of American adults experience migraine headaches. Stress is a major contributor to the frequency and the intensity of the headaches. A massage therapist feels that she has a technique that can reduce the frequency and the intensity of the migraine headaches. Okay, now, part A. Determine the null and the alternative hypothesis that would be used to test the effectiveness of the massage therapist's techniques. Alright, so we know that we are given the percentage. Percentage means proportion. Proportion in decimal, move 2 places to the left, 0.152 p. So we are looking to test the effectiveness of the massage therapist. So before we apply the change to the people that have the migraine, we know that the proportion we have 0.152. The proportion under the normal circumstances before we apply any change, any techniques. This is the existing condition. So this is the H0 for the proportion. And now we are doing testing to see if the massage therapist techniques is really good or not. If the massage therapist techniques is great, then it can reduce the frequency and the intensity of the migraine headaches. And therefore the proportion should be less than what it was given before. So that becomes the alternative hypothesis, H1. Okay, now suppose that a sample of 500 American adults who participate in the massage therapist program results in the data that indicate that the null hypothesis should be rejected. Provide a statement that supports the massage therapist program. So now they said that the null hypothesis should be rejected. If it is rejected, then we can say there is sufficient evidence to conclude that the therapist techniques reduces the frequency and intensity of the migraine headaches in American adults below 15.2%. If her or his techniques is effective, then the proportion of the American adults that have the migraine headaches should be below 15.2, and we have enough evidence. There's sufficient evidence to support that her technique or his technique is helping and reducing the proportion below 15.2. And then part C, suppose in fact the percentage of patients in the program who experience the migraine headaches is 15.3%. Was a type 1 or type 2 error committed? Now this is a type 1 error because the null hypothesis was rejected when in fact it was true. Remember, type 2 error, type 2 has the what? Has 2F. Fail to reject when it is false. But we know that the null hypothesis was true because the null hypothesis say is right here. It's equal to 0.152 152, and then the alternative hypothesis is saying that the techniques of the massage therapist is effective. It's less than, but now in fact it's not less than, it's increasing, and therefore we reject the null hypothesis when it is true. So RT and RT, that should be type 1 error. Okay, let's move on to another topic. Objective: testing a claim. There are 3 methods we can perform to make the conclusion whether we should reject the null hypothesis H0 or we fail to reject. Remember, we never accept the null hypothesis, or we never support it, right? We never accept it. We just say we fail to reject the null hypothesis H0. There's 3 standard ways to do the testing: using the p-value methods, using the critical value methods, and using the confidence interval methods. But in this class, we'll focus more on the first one, the p-value methods. And this one is easy to use because most of the TI-84, 83 graphing calculator, they have the tools, the function for you to find the p-value on the software. And the p-value and the critical value methods, these two, they are similar in the sense that they always give you the same outcome, the same results. And while the confidence interval in the previous chapter is sometimes different from the p-value or the critical value methods, so it is recommended that we use the confidence interval methods to estimate a population parameter only, not for testing. In addition, many technologies, as I mentioned before, can give you the p-value, right? So we focus mainly on how to use the p-value methods in this chapter. Okay, the last objective is to identify the statistic relevant to the test and determine its sampling distribution. Again, the test statistic is the value used in making a decision about the null hypothesis H0. So we have quite a few of the parameters that we saw so far. You can have the proportion, or you can have the mean, right? Proportion or the mean. Proportion is the p. We are talking about the population proportion, so it's p. The mean is mu. Now, for the sampling distribution, for proportion, we always use the normal z, the normal curve distribution, the standard normal distribution for the sampling distribution. And then the test statistic is found by getting the point estimate p hat minus p naught divided by square root of p naught q naught over n. We'll see that more in the next videos. And then the requirements for you to use this formula is that we require n p naught to be bigger than 5 and n q naught to be bigger than 5 for the binomial conditions. For the mean, there are 2 cases: student t distribution and normal z. Now, how do I know which one to use? Well, I check the requirement. We use the student t distribution when the population standard deviation sigma is not given for you. Okay, so when sigma is not null and normally distributed population, or sigma not null and the sample size is bigger than 30. If sigma is null is given, then we use a normal curve, and these two are the test statistic for us to apply. But we'll talk more about that in the next videos for more example. All right, so let's talk about interpreting the test statistics using the p-value or the critical value. The p-value stands for the probability value. This is the likelihood or the probability that the sample will result in a statistic such as the one obtained if the null hypothesis is true. H naught. Okay. Now, the critical region in the left tail. So let's talk about the left tail. This is the left tail. The p-value is equal to the area to the left of the test statistic. The test statistic is right here, and the p-value is to the left of that. The critical region in the right tail is right here. So the p-value is the area to the right of the test statistic. Well, you can see here, to the right. This is the right. Or the case of the two tails. The p-value is twice the area in the tails beyond the test statistic. Double. Twice. Now, if the p-value is less than or equal to alpha, alpha is type 1 error, we reject the null hypothesis when it is true. Right? If p-value is less than or equal to that alpha, then we reject the null hypothesis. If p-value is bigger than the alpha, we fail to reject the null hypothesis. And for the critical value methods, this is a traditional method. We will not focusing more on this method in this chapter, but we focus more on the p-value methods. But again, the critical value methods is that when you find the critical values that separates the critical region where we reject the null hypothesis from the values of the statistic that do not lead to the rejection of the null hypothesis. So if the test statistic is inside the critical region, we reject the null hypothesis. If the test statistic is not inside the critical region, then we fail to reject the null hypothesis. Okay, so that is the end of this video, the introduction to the hypothesis testing. And in the next few videos, we will focus more on how to actually do the testing about a claim.